warahmatullahi wabarakatuh dan selamat pagi kepada semua. So hari ini kita akan masuk tajuk baru. Ni bukan tajuk baru pun sebenarnya kelas, tapi kita dah cover dalam apa kelas? Dalam lab. Alright, so macam yang kita tahu semua, macam kita tahu untuk non-parametric test ni kita akan guna bila kelas? Kita akan guna bila pertama, the data is not normally distributed. So macam mana kita tahu data tersebut tidak normally distributed? So kita akan run test of normality. So test of normality kita akan guna either Kolmogorov or Shapiro nak tentukan whether our data is normally distributed or it is not normally distributed. If it is skewed to the left or it is skewed to the right, so it means that the data is not normally distributed. So when the data is not normally distributed, then we have to use the non-parametric test. Kemudian kita akan guna juga bila kita punya data is heterogeneous, which means it is not homogeneous. Homogeneous ni maksudnya dia macam saya diterang dalam lecture sebelum ni, dia punya mean dengan variance dia tak lari jauh. So when it is heterogeneous, maksudnya mean and dia punya variance tu berbeza. So when it is heterogeneous atau kita panggil sebagai inhomogeneous, we have to use non-parametric test. And then when the data in an ordinal scale ataupun in both are in ordinal scale ataupun one of it is in categorical, then we have to use the non-parametric test. Okay, this we have covered before. So kalau Pearson correlation, the parametric test, kalau to use for the substitute of Pearson when the data is not normally distributed, then we can use the Spearman. Kalau data tersebut independent test kalau data tersebut normally distributed, then we can use independent t-test. But when the data is not normally distributed, then we have to use Mann-Whitney test. The same goes for paired t-test. And when it is not normally distributed, we have to use Wilcoxon. And when Anova, we will use that when the data is normally distributed. But when the data is not normally distributed, we have to use the Kruskal-Wallis. So dia punya cara statistical analysis and the decision making on the statistical analysis sama kelas, which is we are going to refer at the p value. So once p value is less than 0.05, it means we have when it is less than 0.05, it means there is a significant difference. So the main keywords for independent t-test, paired t-test, one-way Anova, the same goes for Mann-Whitney test, Wilcoxon and Kruskal-Wallis. It refers to either they have any significant differences. Okay, class? So for example, like this one. So this tree. So this tree is looking at the differences, class. Looking at what? At the differences. Same goes for this one. Okay, both are looking at differences. So when we say we're going to see differences, then we have to use the t-test or Anova. And if it is not normally distributed, we have to use the Mann-Whitney, Wilcoxon or Kruskal-Wallis. Okay, and the thing is that we have to know that the way you write the research null hypothesis and also the alternative hypothesis is lebih kurang sama macam t-test and Anova, cuma dia berbeza dari segi in terms of you tulis sini median and sini pun median. So for Mann-Whitney, dia punya H0 is there is no significant difference of median BMI between male and female. So male and female, it consists of two groups, and when it is two groups, you have to use Mann-Whitney. So it is a substitute of independent t-test. Okay. And Wilcoxon is the substitute for paired t-test. Okay. So dia sama juga macam dia sama juga macam paired t-test, which is looking at before, which is looking at before and after intervention. It is the same as paired t-test. And the differences only is in terms of the median. So instead you write the mean. Now for Wilcoxon you write the median. Okay. And for Kruskal-Wallis, it is a substitute for Anova. So Anova, you must know that it needs to have more than 2 groups. So when it says it wants to look at the significant difference of median, okay, of median BMI among 3 income groups. So it is more than 2 groups, and then it wants to look at the significant difference of median BMI. So you know it is Anova. And because it is not normally distributed, so you have to use the Kruskal-Wallis. And the thing that is different from Anova is this one. So Anova we write it mean, but for Kruskal-Wallis we write it as median. Okay. The only thing that is different from Anova is that when we find any significant difference in Anova, we have to continue by using the post-hoc test, right? If you still remember, we have to run by using the post-hoc test, normally perhaps Turkey test, right? But for Kruskal-Wallis, if there's a significant output, what you have to do is you have to perform Bonferroni correction. Okay, what is it class? Bonferroni correction. So by doing Bonferroni correction, you decrease the type 1 error that will happen. Okay, so how do you do the Bonferroni correction here? There's 2 ways. For example, okay, there's 2 ways in minimizing the type 1 error. Okay, there's 2 ways. First is that you do the p-value with correction. So once you get the p-value from the test statistic, for example here 0. I think there's something ada salah dekat sini kelas, sorry. It should be 0.14, not 0.014. So 0.14 times by 3, because kalau untuk statistik ni dia ada 3 pasangan, so we have to times it by 3. So you have to this is 0.14, okay, divide by 3. Sorry. times by 3, because it has 3 pairs of pasangan. For example, A, B, C, ada 3 kumpulan, so 0.14 times by 3. Okay, because it involves 3 groups, A, B and C. Okay, so you have to times it by 3. Okay, dan bila you dah dapat nilai tersebut, okay, saya tak ada kalkulator pula dekat sini. So bila dapat nilai tersebut, you akan compare dengan 0.05. So kalau this nilai is less than 0.05, it means it has a significant difference. But if it is more than 0.05, it means there is no significant difference. Ataupun lagi satu cara ni kelas, 0.14 tu you comparekan dengan significant level tu bahagi dengan 3. So significant level kita is 0.05 bahagi dengan 3. So 0.14 ni kita compare dengan 0.016 instead of 0.05. So 0.14, is it less or is it more than 0.016? It is more than 0.016. So there is no significant difference. Okay, it is more than 0.016. So therefore there's no significant difference between A and B perhaps. Okay, I think that's all for non-parametric test class. Thank you very much.